Let's start solving question 1 in this video. So we have to determine the indefinite integrals using the substitution rule. And let's work on question A over here. So this is the integral that we have. What is the intuition of the substitution rule? Well, we can see we have a multiplication of different terms, so we cannot use our power rule of integration directly, meaning we must write this in a shorter way. So let's see how that's going to work out in this case, and then we'll understand the method of doing so. For instance, let's call that new term, the term that we're going to substitute, u. That's usually the convention. So if we call that a u, and let's call that u an expression out of all this integral. And let's take that expression as x to the power of 10 minus 7. So if u is equal to x to the power of 10 minus 7, let's see, if we differentiate u with respect to x, what do we get? We would have du with respect to dx equals to, what is the integral of x to the power 10 minus 7? Well, that's just 10 times x to the power of 9, right? Because 7 derivative is just 0. Now we can understand why we did so, right? The idea is this: we took this term not just randomly, we took it for a reason, because now we can see a relationship between x to the power of 9, there is a 10 in there, so 2000 is 10 times 200. The idea is this: whatever we're going to substitute, we have to do it with the purpose of connecting that with whatever is left in the integral. So in this case, if we substitute this expression with u, and then we're left with 10 times x to the power of 9, then the remaining terms that are left over here, we could also write them in terms of du. So we will have the new integral based on this new variable u. Let's see how that works out. So let's keep going over here. If du over dx equals to that, well then du is equal to 10 times x to the power of 9 times dx. We just do a cross multiplication over here. Now with this said, we're getting closer to where we want to go. Let's see how that works out in this integral. How do we substitute everything over here? Well, we'll have our integral, and let's see what we're left with. So we have 10 times x to the power of 9 times dx. Well, watch this. This is dx. This is x to the, actually let me color in in the same color all these terms so that we can connect them. So dx, like that, x to the power of 9, and we also have 10 from here. We don't have 10 explicitly in the integral, but we have 2000, which we could write as 10 times 200. So this will be 200 multiplied with 10. Now, with that said, we could rewrite this integral, because we'll have 10 times this term times dx is gonna be equal to just du. So we have du already. We have du. What is left? We're left with 200, so we write 200 as well. And what else do we have? We have u, right? This entire term is substituted with u to the power of 99. So we write u to the power of 99. Now this is what we started to do, right? This was the entire purpose, because we have the integral written in a shorter way. And indeed we have an integral with one variable only where we can apply the power rule. So we'll do so. The 200 is a constant which can come out, so we will take it out of the integral, and we will have 200 multiplied with the integral of u to the power of 99 du. Now we can use our power rule of integration. So we have 200 times u to the power 99 plus 1 is 100 divided by 99 plus 1, which is also 100 plus a certain constant. Now we can simplify some things. 200 and 100, they cancel out, and we're left with 2. And to write the final answer, we'll write it in terms of the initial variable, which was x. Now what is u? u was x to the power of 10 minus 7. So we're going to substitute it back to give the final answer. So that as a result, we're left with 2 times x to the power of 7. X to the power of 10, minus 7 to the power 100 plus c. And that would be it. Hope this makes sense. In the next video, we go to part B.